last speaker, I can see I'm amongst friends, and you're glad to have me here. And I can assure you, we are not the enemy, and that we are here to partner with you to make sure that we can succeed. So, although there was a bit of comments against Eskom, and I can appreciate why the feeling is that way, I think there is a lot of diversity within Eskom that is often compacted into one area of load shedding. And I hope that the presentation today will be able to provide some insights on where value actually exists and why you want to partner to create success. All right, next slide, please. There's it. All right, next slide. So first of all, I think I would like to give you an overview of what the grid looks like. So in South Africa, there's about 35 gigawatts of load, and it's really split almost 80% in the blue area and 20% in the south, with most of the concentration of the load in the north in Gauteng and KZN along the coast. And the dominant load in the south is actually on the coastal areas as well. If you can click. The generation currently is dominantly in the north as well. Almost 80% of it's in the north, in the black area, and with about 20% in the south. So quite a good distribution of generation and load located with each other. If you can click again. The conventional plant, dominantly coal, is in Mpumalanga and Limpopo, with very little generation elsewhere in the country. Only nuclear in the south, with a bit of hydro spread and pump storage in other areas. And in order to facilitate the movement of power to where the economics are, we really have the transmission grid. This is the bulk carrier of power to all the customers. It's dominantly a 400 kV network. The large power lines, 400 kV, and our largest power lines are the Cape Corridor, which is a 765 kV corridor, which is shown by the red lines. The network is designed to supply the volumes of load in the particular area. So if you can click again. Thanks, and again. So the dominant area where we have capacity in the south is about 5 to 6 gigawatts. So the entire Cape area is about 5 to 6 gigawatts, and hence the corridor is designed for about 5 to 6 gigawatts to supply the power. Next one. Now there's a significant change in building, and as you've spoken of, renewables are key to this build, and this is in the government's plan of the IRP, which had a significant amount of renewables in the original IRP. Almost 70% of it was renewables. And these locations then become important because the higher quality renewables are located in specific areas, and they reduce the cost significantly. So this is the range of the various resources that are in the IRP. The two at the top are the dominant ones. The top one is solar, and the second one is wind, where the red indicates the high quality resources that are in the country. If you move to the next slide. This shows the environmental impacts, the areas of which it is undesirable to have, or not possible, or very difficult to have the various plants located. And this can be for various reasons: bats, birds, the terrain, various site locations, etc. So there's a multiple mapping that has been done, and these indicates the challenges in areas to be able to place renewables. Next slide. So if you eliminate then the challenges and you have a look at where are the actual locations that we can place the renewables of high quality, you get very discrete areas that you can place them. The upper one shows the solar, the second one shows the wind. One of the clear areas is that there's high quality solar across the northern belt from west to east. As you move towards the coast, it becomes significantly poorer. This wind, you'll see that it's clustered in the south of the country, so the Greater Cape area. There is potential in Mpumalanga, but it is much more limited than what it is in the rest of the country. Next slide. Okay, go again. Go again. So in the original plan, the energy availability factor was significantly higher than what we see today. And what that has done is that we had to increase the amount of renewables in the short term significantly to close that gap. And we also need to supplement it with batteries to support the grid, because the solar and wind are variable. So when they are not available, you need something to be able to ramp up and to take its place. So gas and batteries are critical in the elements to be able to mitigate those variability. Now, we did a survey with the renewable industry to say, where are the projects? We heard today there's 6 gigawatts that are required by 2030. This is not an insignificant amount. So we asked the renewables associations, where are you wanting to develop projects? The yellow shows the solar projects, the green shows the wind projects. And they indicated that there's in interest about 64 gigawatts of renewables, of which 35 was wind and 29 was solar. But it's really important to have a look at the displacement of where the resources are and where the corresponding developments need to be. And if you overlay that on the resource maps and the constraint maps, this is for wind, you can see they very highly correlate to those resource maps. And they are located in the areas. In the solar area, where there's very difficult air environmental conditions, there's in KZN almost no wind projects, although there are very good resources. In Limpopo, the same results. If we look at the solar, we see very similar pattern, great solar resources. We can see the locations of the solar resources, but we can see where there are problems or environmental constraints and difficulties and higher costs, there is lower interest in the areas. So what we see is that in the near term, the development plan that we plan the transmission grid has really accelerated because of the lack of performance in the generation area, a significant amount of wind, solar projects. And this brings its own challenges. So we'll see in the near term here, it's not too clear on the slides there, but the timeline with the bar chart indicates the huge volumes of renewables that are required to come in the earlier period. And that volume that needs to be brought in requires to be connected to the grid. And if you remember, we said that the location of the renewables, you can go on, because of these environmental constraints, are located in the area where the grid has actually got the lowest amount of load. We've got about 6 gigawatts in that entire area where you've got all these renewables, but you've got 57 gigawatts that want to come in that area. So this automatically creates an imbalance, that you've got higher volumes of renewable plant that are variable, and you've got load which is significantly lower. And the dominant load sources now are in the north. And this then is a transportation problem. How are you be able to collect all these renewables, be able to manage their variability, ensure security of supply, and transport it to where they're required to go? You can just keep going. All right, next one. So in order to indicate what capacity there is on the grid, the main congestions of the grid, as mentioned by the speaker, we've got 6,300 megawatts of renewables already in the grid. But we've only got 6,000 megawatts of load in that entire Northern Cape, Western Cape, Eastern Cape, Free State area. Plus we got Kuiberg, 1,800 megawatts, plus we got 1,800 megawatts of gas. So when all of these renewables start putting together, there is more generation in the area than there is load, and the power starts reversing along the corridor and rapidly starts eating up the capacity. Where the black dots are, this is a capacity map on the transmission grid, and this is available to the public on the transmission website, on the Eskom website, and it shows what is the capacity available on the grid. This was the capacity available before bid window 6 that came on. The black dots indicates where there is no more capacity on the grid. So in the entire area, and the reason for this is what has been committed in that area where the black dots are is over 3,300 megawatts of renewable plant. The total load at midday in that area is about 900 megawatts. So the distance from the Uppington to the nearest load center is 800 kilometers. So now we've got a local load of 900 megawatts. We've got 3,300 megawatts of wind and solar coming, and the closest place we can move the load to is almost 1,000 kilometers away, 800 kilometers away. And this causes transmission congestion because the original network was designed for the 1,000 megawatts, not for 3,000 megawatts. So you need a rapid build out on the transmission grid to facilitate that local generation capacity and unlock them, and you need to be able to capacitate that network to be able to harvest the renewables and share it amongst all the people who want to use it. So if we look at the capacities in this area, the entire area before bid window 6 only had 5,000 megawatts left. Okay, and basically what that is that you've put the generation in the area, now you're reversing the flow back up the corridor, so that's the remaining capacity. If you click on, we still have capacity in the north of the country, almost 14 gigawatts. So we originally had about 32 gigawatts left in the entire country, but the dominant areas where there's large capacity, which is KZN and Mpumalanga, because that's the dominant loads, are constrained in terms of the ability to put your renewable plants. So you are segmented more to about 19 gigawatts prior to bid window 6. If you click onto this. This is why there's a lot of focus on Mpumalanga to encourage the renewable plant in that area, because it's one of the highest capacities that we have on the grid. There is coincidence of good wind and some solar, and therefore the intention to put it in that area to utilize that capacity. If you just click on. The Greater Cape area with only 5 gigawatts left is problematic because there's a huge interest, if you click on the map, of 57 gigawatts of interest from the market to connect to that area. Now you have to rapidly build out network over long distances to be able to facilitate this, to move the product to the market, which is effectively the northern load in the country. You can move on into this. The interest in the other areas, Limpopo, Gauteng, and KZN, is only 0.3 gigawatts. So although there's grid capacity there, the locations where the high resources are in a very different location to what we have. If you click on this area. Okay, you can go. So the problem here is that the dominant load is in the north, and it's going to remain very much the same over time. And the changes in the generation mix is significantly changing over a very rapid period, and this is causing grid constraints. So in the Netherlands, which was mentioned as coming here, the Netherlands and all other grids around the world are experiencing the same problem. The Netherlands grid is totally congested in the north. They've got zero capacity left for both load and generation, and they are constrained. And one of the issues is that with renewables, you build in 3 to 4 times as much capacity than what you normally have, which rapidly consumes the transmission capacity that you have. And so in order to facilitate this capacity, you can click on, what we really need to do is we need to harvest the renewables. In the past, the networks were designed almost, the example I use is like fishing. If you want to, it's the large plants were like fishing for marlin. One big rod, transmission, one big capacity you have to collect. And that's how you designed it. Renewables are very different. They're like sardines. And when you fish for sardines, using a rod is very ineffective. You need a net to harvest it because they pop up wherever they pop up at any time. Very similar, what we require here is a meshed grid around the Greater Cape area to harvest the renewables whenever they pick up to ensure security of supply. Because if clouds come over, if wind is lulled, somewhere in the country there is renewables, but unless there's grid associated with, you can't move the power to where the load is and harvest it. So what we require is to expand the grid to an area where we can create access and be able to create reliability by moving the power across the grid to the right areas that we need. So in this regard, we publish what we call a transmission development plan. The development plan looks at the time horizon of 10 years, and it provides the expansions that are required to facilitate the reliability of supply. And this security of supply that we are all concerned about has many components, as was alluded to. One is the generation side, which has many players in it, of which Eskom is one. There's private sector, there's multiple households, there's small embedded generation. All of those players are part of the solution to the energy problem. There's another part of the problem, which is the transmission grid. We need to be able to connect and harvest and move the power to the right places. If we don't have that capability, it becomes problematic to have reliability, lowest cost. And those are very sensitive areas that we have. And then you have the distributors, which are also multiple players that we have, not just Eskom. So we have multiple facets in this reliability of supply. Key to it is if you do not have a transmission grid that is facilitating the movement of the power and reliability, there is limited chance of success. And this is a global requirement. Every single grid is rapidly running out of power and is rapidly requiring expansions, and is recognized as a key facilitator, the foundation for a large renewable uptake. So these are our plans, and as you can see, what we are facilitating is that meshed grid, large capacity corridors with mesh networks to able to harvest the energy that is produced by whoever, create open access on the grid, and allow for the connections of the renewables to happen. What is critical is that this happens as fast as possible, because the constrained grid is rapidly limiting the amount of renewables that can connect. Next slide. The key element to building the transmission lines is it takes us currently about 10 years or longer. The reason why it takes us this long is the EIAs are fairly rapid. We've got a great collaboration with DFFE to accelerate these within critical corridors, which have been legislated. The execution is done by private sector through open tenders, and we can execute that between 3 to 4 years. The biggest challenge we have is that the ability to acquire the land to build these lines is our stumbling block. It takes us between 7 to 10 years, sometimes even longer, to negotiate these routes across all the landowners. And you can imagine negotiating this over 1,000 kilometers for multiple lines, the constraints that we have. This is our biggest hurdle to create capacity for you, to resolve your problems. And a lot of the times, these lines go over the same land that you want to secure your security of supply. We need your help to be able to acquire these servitudes as fast as possible so that we can help you connect as much generation to resolve the problems of inadequate security of supply. So it's really important to add new generation onto the grid. But if we don't have grid, we can't add it on. The ability to get grid lies in the hands of the landowners who can give us access to build those lines. The faster we can get it, the faster we can build it. So it's really important that these expansions of these long lines to create access, the ability to trade, to sell that excess, to have multiple opportunities as agriculture, to not only do farming, but other forms of utilization of your land, that we can provide this access to you. And we really are appealing to you to assist us, to find a way to accelerate the ability for us to create opportunities to build these lines over these long distances. Next one. So what is really important is that we need to add more generation as fast as possible. What is critical is that we need collaboration to accelerate the ability to build these transmission lines. We also need a better understanding, and I heard the speaker before speak of the collaboration that didn't provide much success. But it's really important that this takes place, and I'll give you an example why. In the Northern Cape, the limited load that we have is problematic if that load is not correlated with the generation. If we know we've got excess generation during the daytime because we dominantly got solar, well, ideally we would want all the load to move into that same solar area to minimize the amount of grid capacity that we need. So the coordination of how we combine the efforts to minimize these impacts become really important. To understand where your critical times are to produce, to understand what the impacts of excess generation in these areas become really important. The battery program just released by the IPP office, we recommended that the batteries go in the Northern Cape for this exact reason. To add additional capacity, store the sun during the day, release the constraints so we can add more renewables. But the load itself plays a key role to understand how to coordinate that load within that area. And the more and more we pack the excess generation, the more and more secure that local area becomes. And the more important it is to coordinate the importance of the load and the generation time zones together. So it's really a plea to say we really need assistance to build these transmission lines out. We really need a collaboration to be able to find ways to get these servitudes as fast as possible. And we'd really like to get a greater understanding of how we can collaborate to improve and limit the stress on the grid while we are building these lines out over in time. So thank you very much for your time.